welcome to episode 3 of the Markov manner from 0 to Pro in C#. You made it to lesson 3, and today we do magic. We are going to build your first actual program. A calculator that takes input from the keyboard and does basic math. It's all in text, all in the console, and 100% powered by your code. Let's go! So we are going to start our calculator, and the first thing we have to do, sadly, is to get rid of all this code. We will do some new fancy code, don't worry about it. First things first, we need two numbers. So let's ask the user to type two numbers for us. And hey, we are only doing whole numbers for now, so no decimals, okay? We will get fancy later. I've prepared the code beforehand, so let me just copy it and paste it here. This first line, you already know what it does. It presents this message to the user, he will see it and can interact with it. Now that second line, the string input 1 is set to that Console.ReadLine. What it does is, it waits for your keyboard input, like freezing time until you type something and press enter. Whatever was typed is now the value of the variable input 1. That's super cool. Now we can do the same for a second number. Let me just copy this and paste it here. It's exactly the same thing, we're just setting a new variable with a new Console.ReadLine. Alright, so here's the deal. When you type something into the console, it's always treated as text. Even if you type 42, it's actually quote 42 quote, but the quotes are invisible. And C# is like, bro, I don't know how to do math with words. You can't do math with banana or pizza, you need numbers. So we convert that text into a real number by using the following. Get some new lines and type int num1 equals to convert to int 32, open brackets, input 1, semicolon. You can do right now the same for the in number 2, is just press tab and Visual Studio will do thing for you. If it doesn't, just write it down. This is like telling C#, hey, trust me, this string is actually a number, and if it isn't, you just crash. There is always someone who do not read the instructions, and they will type banana. Trust me. So to save the day, we will wrap all of this into a try-catch block. Think of it like putting a safety net under your code. The try part is like, hey computer, try this. The catch means, if it blows up, don't panic, here's the plan. So how do we do this? Type try and press tab twice. It will do this. Now, select all the code that we had and press Ctrl X. Go and insert the cursor inside the try block and Ctrl V. Now we are safe. So if the user types something weird or divides by 0, your app will not crash. It will throw a friendly message instead. So now we miss the operation that we want to do. Let's ask the user for it. We will offer 4 possibilities: addition, subtraction, multiplication, and division. So let's inform first the user what are the possibilities, and let's do Console.ReadLine, choose an operation, and let's put it add, subtract, multiply, or divide. That's fine. And now, using the same strategy as we did for the numbers, let's retrieve the value and store it in a variable. So string operation equals to Console.ReadLine. And that's it. So now let's create our variable to hold the operations result. So let's call it int result equals 0. This will allow us to make the operations and store the result as we want. Now let's use some if-elses, one of the superpowers of computer science. An if statement lets your code make decisions, like if the user typed add, then you do addition. So if you go here and you type if operation equals equals, and this is not a typo, equals equals means is equal to in C#. One equal assigns the value, two equals compares the value. So if operation is add, then we will do some stuff. We'll put some curly brackets to indicate so. And what we will do is our result will be equal to num1 plus num2. That's fine. But we have more operations. We have the subtract, the multiply, and the divide. So we can use else because we do not enter the add, and we can do another condition right after. So else if operation is subtract equals equals subtract, I want to do the subtraction of it. The same for multiply, else if operation equals 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 multiply, then I want to do is multiply the numbers. That's fine. Now the divide case, else if operation equals equals divide. As you can see, Visual Studio is giving a very big hint here, and we have to do something about it, because he's right. Division is a little bit spicy, because if someone tries to divide by 0, boom, the program crashes. So we have to handle it. We can do another if inside this if to see if the second number is a 0. If num2 equals equals to 0, we can immediately say to the user that we cannot divide by 0, something like this. Now, does it make sense to continue operating the program? No, not at all, because this is a math error. It's not a computer error. So we can exit immediately what we are doing. How do we exit? We just type return semicolon. This is like, I'm done, I don't want to do anything below this, I'm out. If the user just inserted a non-zero number as the second one, we can continue the operation. And in this case, it's just a simple else, because you do not need to do any new if statement for it. So it would be something like this. If it's different than 0, we'll enter the else clause, and the result will be equal to num1 divided by num2. Now, what if the user types in operation something weird like explode or banana as the operation? Well, boom, default fallback activated. It's like your code saying, I don't speak that language. So we have to introduce a final else case. I've already prepared it. Let me just copy and paste it here. All right, if everything went well, time to show the answer. And to show the answer, we're going to put our cursor here, and we are just going to Console.ReadLine the result. Now, here's your full try-catch, all wrapped up like a pro. So let's just change this message here to something more understandable to the human eye. Let me just copy from here and paste it. And that's it. You built a full working calculator. It reads input, makes decisions, catches mistakes, and gives answers. You are now officially dangerous. Wait. Quick heads up. If you try 3 divided by 2, you will get 1. Yeah, it should be 1.5, but our calculator only works with whole numbers right now. It's using something called int. Why? Because we haven't taught the calculator how to handle decimals yet. But hey, that's a bug with a plan. We will squash it in the next lesson when we introduce something cooler. Decimal numbers with doubles. So for now, just imagine it working and keep it rolling. You made it! You created a C# calculator. In our next lesson, we will go a little deep into logic. We built a real calculator. Yep, you actually wrote code that takes user input and does math. That's wild! You are officially speaking to the machine now. Our next class, we are turning that brain power up a notch. We will dive into if-else, next-level logic, aka decision-making like a boss, switch cases, cleaner paths, cooler choices, loops like for and for each, so you don't repeat yourself unless you mean to. And we will crack open the magic of algorithmic thinking. It's like giving your code even more superpowers. Let's keep building. This is the Markov method.